Hi guys, we're going to do the class notes for 7.1. So I'm going to try and write legibly on here. Try to listen. You'll be able to hear what I'm writing. So that way, if it's not legible, then you will be okay. All right. So again, 7.1, get to that section in your notes packet. We're going to start at the bottom of the first page of chapter 7. And we're going to look at cations. Okay, so the key sentence for cations is a positively charged ion or cation is produced when an atom loses one or more valence electrons. So that should make sense. Losing electrons is losing negatives. That makes you positive. Okay. Now, names of cations compared to their metals, well, they keep their names. So calcium is still calcium when it becomes an ion. We might say calcium ion just to specify, but its name is calcium. They keep their names. Properties of cations compared to their metals. Hopefully you have something written there that says they are very different. Example, reactivity. If you want to write that, reactivity. Sodium is a metal. Na is a metal. It's super shiny. It's soft. When you throw it in water, it explodes. Okay? That's the reactivity part. It explodes when you put it in water. But we need sodium ions all the time. We probably actually consume too many of them in the form of salt. But when you put salt in your mouth, it doesn't explode. So when we change from an element into an ion, the properties completely change. Okay? Now, at the bottom, we've got group 1. They all have one valence electron. Let me show you this. If we've got our periodic table and you're writing an electron configuration for any element over here in group 1, okay, they're all going to end in S1. So like 1s1, 2s1, 3s1, 4s1, etc. They're all going to have one valence electron, okay? And our octet rule up above says in forming compounds, atoms tend to achieve the electron configuration of a noble gas. In other words, in order to be stable, an element needs the electron configuration of a noble gas. So if it only has one valence electron, well, it could gain 7 to become like a noble gas over here. But that's a lot of work, okay? What actually happens is it loses that 1. So if sodium, for example, sodium loses that 3s1, that entire orbital disappears. And now we're down to 2s2, 2p6, same configuration as neon, and that is stable. Okay, so group 1, one valence electron, lose it, become a +1 ion. Group 2 have 2 valence electrons. They're going to lose them and become 2+ ions. So hopefully you already had those, okay? Have those things written for group 1, group 2. Now transition metals, this is where our class notes begin. Transition metals in that box. How does that look? Can we see that? Okay, transition metals. The charges of transition metal cations can vary. The charges of transition metal cations can vary. We're not going to be very specific on that. We're not going to teach you the ins and outs. That's inorganic chemistry. You can take that in your 3rd or 4th year of college if you'd like. But we will work more with transition metals later. And then aluminum. I was a little bit surprised the book didn't include aluminum. Okay. Now, aluminum, if I were to ask you how many valence electrons it has, you could write out its configuration and figure that out. Or if you look at whatever group number it's in, right here, aluminum is in group 3A. Okay. Any A group number, that's the number of number of valence electrons that atom has. So aluminum is in group 3A. It has 3 valence electrons. Okay? It has 3 valence electrons. That's still not halfway to 8. Okay? 8 is that noble gas configuration we're trying to get to. So it's going to lose all 3. Loses all 3. Becomes Al3+. Al3+, a 3+ ion. When you lose 3 negatives, you become a 3+ ion. Okay, on the next page, we're going to look at electron configuration of cations. Electron configuration of cations. So this is a big section of class notes in comparison to what we've done so far. So we're going to write all this out for cations. So first of all, metals tend to have 1 to 3 valence electrons. 1 to 3 valence electrons. Okay, so they're not even halfway to that stable octet that we're looking for. They will lose all valence electrons. They will lose all valence electrons. They will lose all valence electrons to get to the octet underneath. To get to the octet underneath. They will lose all valence electrons to get to the octet underneath. Okay, now we're going to do an example of this using sodium. Okay, so for Na, sodium. I know I've already talked about it, but we're going to just go ahead and write out its electron configuration. It's 1s2, 2s2, 2p6, 3s1. Can't go too far there, okay? So 1s2, 2s2, 2p6, 3s1. Now, how many valence electrons does sodium have? Again, you can look here. This is the highest energy level, level 3. It has 1 electron there, so that's 1 valence electron. Okay, 1 valence electron. Ooh, that's too small. All right. We'll write it up here. 1 valence electron. Okay, or you can look at its group number. It's in group 1A, and the A group numbers also tell you the number of valence electrons. So it has 1 valence electron. Okay, now I've just told you they're going to lose all of their valence electrons. So we're going to show you why. When we take away that last valence electron, the entire 3s disappears. And what I'm left with is 2s2, 2p6. 2s2, 2p6, that's 8 valence electrons. That's stable. Okay, so it will lose 1 electron. It will lose 1 electron, okay, leaving Na plus. Okay, again, losing negatives makes you positive, so Na plus. Na plus. And its new configuration is 1s2, 2s2, 2p6. Okay, 1s2, 2s2, 2p6. And that has 8 valence electrons. Stable. Okay, if you were to write the abbreviated electron configuration, you would just have Ne in brackets because it's the same as that noble gas. Okay, now we're going to scooch over to anions. So the next part of your notes here is on anions. Okay, an anion is produced when an atom gains 1 or more valence electrons. So gaining negatives makes you negative. Anions are negative. Okay, and their name actually does change. So their endings change to "ide." So chlorine gains an electron, becomes chloride. Sulfur becomes sulfide. Tellurium becomes telluride. Okay, so their ending is going to change to "ide." And again, their properties super different than their atoms, their elements. So for example, chlorine gas, toxic green, pale green gas, you definitely, sharp odor, you wouldn't want to be near it, okay? But chloride, again, is part of table salt, sodium chloride. We eat it all the time. It's not poisoning us. Too much sodium can be harmful. But anyway, we eat it all the time, okay? We drink it all the time too. It's in our drinking water. So, totally different properties. Definitely want to get that. All right, electron configuration of anions. So we're going to do kind of a similar thing for anions, okay? But anions happen with our nonmetals. So nonmetals typically have 5 to 7 valence electrons. Nonmetals typically have 5 to 7 valence electrons, so they're really close to having an octet, okay? They will gain the difference to get to 8 valence electrons. They will gain the difference to get to 8 valence electrons. They will gain the difference to get to 8 valence electrons. Okay, So we're going to do chlorine as an example. Since we use sodium, we might as well do chloride and just get table salt over with. Okay, so for example, chlorine. Okay, full configuration: 1s2, 2s2, 2p6, 3s2, 3p5. 1s2, 2s2, 2p6, 3s2, 3p5. How many valence electrons is that? Okay, you can tell by looking at our highest energy level, has 2 here and 5 here, that's 7. Or look at its group number. Okay, use the cheater way from now on, guys. Okay, cheater way is look at the group number. Group 7A have 7 valence electrons. So 7 valence electrons. Not stable. Okay, we're looking for an octet, 8 electrons. So what is it going to do to become stable? It will gain 1 electron. It will gain 1 electron to complete its octet. Okay, so it will gain 1 electron to complete the octet. Okay, so it becomes Cl minus because it's gaining that negative. So Cl minus, okay, that's chloride because it's got a negative charge. Also, one more thing to mention here. If it's going to gain 2, then we would write 2 minus. Or if it gains 3, we would write 3 minus. We don't have to write 1s, but if it's more than 1, you always have to write that number as well. Okay? But chloride, its configuration, 1s2, 2s2, 2p6, 3s2. We're gaining 1 now, so we're adding 1 to the end. So we get 3p6. Okay? And that is the same configuration as argon. Okay, so chlorine, when it gains 1 electron, it gets the same configuration as argon. Now, really careful with this. It is not becoming argon because it still has 17 protons. So protons define it as chlorine. Okay, electrons can become the same as argon, same configuration, but it's not becoming argon because it still only has 17 protons. So please make sure that you know it is not becoming a noble gas. It is getting the same electron configuration as a noble gas. Okay, so there we are, octet, 8 valence electrons, stable. That's why sodium and chloride are such good friends. Okay, sodium wants to get rid of 1 to be stable. Chlorine needs to gain 1 to be stable. So we get sodium positive, chloride negative, stick together, ionic bond, sodium chloride. Okay, so we're going to work a lot more with this as we go through chapter 7, ionic bonds, ionic compounds, and you're going to get a lot more practice with this with the formation of ions activity next. All right, we'll see you guys in class.